Okay, in this video I'm going to walk you through homework number 23, which a few of you have asked about. So looking at my reference sheet, I know that cot could be expressed as 1 on tan, but I also know cot can be expressed as cosine on sine. So without having explicitly mentioned it, I'm working with the left-hand side. So the left-hand side is 1 plus, and immediately I'm going to switch cot to cos on sine. On and cosec, if I look at my reference sheet again, that's 1 on sine. With time, I hope that I would have that memorized, but given that you've only just learned these, please have the reference sheet in front of you or a copy of the reference sheet so that you can reference it. Minus, I'm going to do the same thing with the other fraction that secant is 1 on cos. Tan is sine on cosine. Cot is again cos on sine. Oh, I don't really like that one. But now I've got this really messy business with fractions within fractions. So I'm going to do what I loosely call clear the fractions from within the fractions. Meaning, if I look at this first fraction, I don't like the fact that on the top I've got on sine and on the bottom I've got on sine. Another way to say it is you can simplify this fraction and a fraction by same change flip, which some of you do well, some of you could use some practice. But I'm going to multiply the bottom by sine, because when I do sine times 1 on sine, that's actually going to become 1. And therefore I no longer have a denominator in the original fraction. I'm going to do the same thing on top, multiply by sine. Again, sine on sine is 1, but when I distribute into the brackets, it'll clear the second fraction, the cos on sine. So multiply sine times 1, so that's sine theta. Sine times cos on sine becomes cos, because the sines cancel each other out. And technically we've got on 1, because sine times 1 on sine, they're reciprocals of each other, and therefore you have 1. So that on 1 is not necessary. Looking at the second one, this one's a bit messier. And the reason it's a bit messier is because in the denominator I've got sine on cos plus cos on sine. Not common denominators, but not completely sunk. I can simply multiply by the common denominator of cos sine, as long as I do the same thing to the top, cos sine. So therefore when I multiply 1 on cosine times cosine, those are reciprocals times sine, so I get sine on top. When I multiply cosine on sine times sine on cos, again, those cosines cancel out, leaving me with sine squared for that first fraction in the denominator of my original fraction. Plus, when I multiply cos times sine times cos on sine, the sines cancel out, leaving me with cosine squared, which is good, because if you are paying attention to your reference sheet, you know that sine squared plus cosine squared is a Pythagorean identity, and that is also 1. So I end up with sine theta plus cosine theta from the first fraction minus sine theta from the second fraction, because that denominator, this one, equals 1 from the Pythagorean identities. Again, that one is explicitly on your reference sheet. And luckily, the sine minus the sine cancel, leaving me with cosine theta. And if I go back and I look at my original problem, cosine theta is my right hand side, so therefore that equals the right hand side. And that's what I was requested to prove. So therefore I have proven that if I simplify the left hand side, it does in fact simplify and become equal to the right hand side.